good morning, good afternoon, good evening, depending on the time you are watching this video. I am Mr. Debrian, your chemistry teacher in the platform School for All. So due to the high demand of our students in understanding some organic chemistry concepts, so I've decided to produce this video which explains how reagent and reaction mechanisms are going on in organic chemistry. So don't forget to like the video, subscribe to the channel, share, comment, and put a click on the notification so that new updates should be given to you. So in organic chemistry, all of us know that in chemistry, all we know that a reaction is between a reactant that will give a product. That will give you a product. Now, the reactants are subdivided into reagent and substrate. Reagent and substrate. What is a reagent? A reagent is a molecule that will attack a substrate. Now, what is a substrate? A substrate is a molecule which is having an active site or a reactive site where the reagent will attack. Okay? Alright. Now, in organic chemistry, we are going first of all to base ourselves on the types of reagent. And we have basically three types of reagent, which are nucleophilic reagent, electrophilic reagent, and free radical reagent. Now, what is an electrophilic reagent? An electrophilic reagent is an electron-rich species that attack the electron-deficient site on my substrate. Example, there are what? We have Cn minus, we have OH minus, and we have Cn minus. So these are the example of the nucleophilic reagent. Now, electrophilic reagent. What is an electrophilic reagent? An electrophilic reagent is an electron-deficient species that goes to the electron-rich side of the substrate during chemical reaction. So generally, they are the one having a positive charge. So example, I will have NO2 plus. I can also have PR plus. Alright. Now, free radical reagent. What are free radical reagents? These are highly reactive species which are formed during homolytic bond fission. So, highly reactive species with an unpaired electron which are formed during homolytic bond fission. So, example of free radical, you simply put your Cn. So that's an example of free radical. As you know already the types of reagents, now we are going to discuss about the types of organic reactions. So three types of organic reactions, which are substitution, and addition, and lastly elimination reaction. Now, depending on the type of reagent which is attacking, you are going to have the different types of organic reaction which are further subdivided. So, for example, when you go to substitution, it will be separated into nucleophilic substitution, electrophilic substitution, and free radical substitution. And this electrophilic substitution will be also divided into SN1 and SN2. Now, addition reaction will be separated into the two types, which is nucleophilic addition and electrophilic addition. And lastly, elimination will just be separated into E1, that is unimolecular elimination, and E2, that is bimolecular elimination. Now, let us enter into the different types of organic reactions and their mechanism. So what is a substitution reaction? It is simply a reaction in which an atom or group of atom is replaced by another atom or group of atoms. Nucleophilic substitution reaction are simply reaction in which an atom or group of atoms are replaced by an electron-rich species. Now, this nucleophilic substitution reaction occurs for halogen alkenes. Because halogen alkenes, I hope all of you know that halogen alkenes are simply alkanes with one or more halogens. Now, halogen alkenes generally represented as RX. So if you know a nucleophilic substitution reaction is generally a reaction which occurs in what halogen alkane. So it is on the form that I'm having a halogen alkane, I will replace it. I can replace it with this, or I can replace it with this to form either an ROH, which is an alcohol, or an RCN, which is what an alkyl plus the regular. So that's generally what the principle in nucleophilic substitution reaction. But we have said that the nucleophilic substitution reaction occurs in two mechanisms. That is SN1. What is the meaning of SN1? So to read the name, we start from reading here, going in this direction. So we call it SN1 because the name is unimolecular nucleophilic substitution. So it is called SN1 because the name is unimolecular nucleophilic substitution. Unimolecular nucleophilic substitution is having some special characteristics. So the characteristic of unimolecular nucleophilic substitution reaction is that it occurs in two steps. It occurs in two important steps. The next characteristic that you are supposed to know is that why is it called unimolecular? Because it has what? One species in the rate determining steps, that is the slow step which determines the rate of my reaction. Next thing is that in this type of mechanism there is what? A carbocation formation. So the formation of a carbocation. And the last characteristic you have to know is that this reaction generally occurs for tertiary haloalkanes. So I hope you know the difference between primary, secondary, and tertiary haloalkanes. A brief review on it is that a primary haloalkane, it is a haloalkane in which the carbon atom directly bonded to the halogen is having two or more hydrogens. So that's the primary haloalkane. What is a secondary haloalkane? It is one in which the carbon, which is directly bonded to the halogen, is having only one hydrogen. So that's a secondary haloalkane. And the tertiary haloalkane is one in which the carbon which is directly bonded to the halogen is having no hydrogen at all. So that is primary, secondary, and tertiary haloalkane. And we say that unimolecular nucleophilic substitution reaction occurs only for tertiary haloalkanes. Now, example, I will substitute the chlorine atom to form alright, so this is an example of a reaction. So I can have this compound which is a tertiary haloalkane and I will replace the chloride with the OH minus ion. So how does the mechanism look like? So the mechanism, I will first of all have my formation of my nucleophile, which is not considered as a step here. So I will simply dissociate this into this and this, and of course this is what my nucleophile because it's what my electron-rich species. Now what happens here is that I will have my organic compound. Due to inductive effect, this carbon is sufficiently supplied with donating group, so this chlorine can easily disappear. To form my carbocation. Which is my slow step since I'm having one species in my slow step, I call it what? So I'm having one species in my slow step, I call it what? SN1 mechanism. I form my carbocation. Now my second step is that after my carbocation formation, my nucleophile will attack. And remember, the arrows always move from negative to positive. So finally, I will form my compound CH3, CH3, OH, and this chloride ion will come and form a counter ion with what? Sodium, forming sodium chloride. So this is my mechanism of SN1. Now it is clearly understood. Let us now go to SN2 mechanism. So it is the same principle to give the name now. SN2 means what? Start from here. It means bimolecular nucleophilic substitution. Bimolecular nucleophilic substitution. Now, as in SN1, this bimolecular nucleophilic substitution is also having some particular characteristic. So the first characteristic here is that it occurs in a single step. It occurs in a single step, unlike SN1, which occurs in two steps. Now, the next thing is that the SN2, here is what is no carbocation formation. No carbocation formation. The next thing is that what? Next thing again is that it is called SN2 because it has two species in the rate determining step or the slow step. And the last characteristic is that what it occurs primarily for primary haloalkenes. We are going to discuss earlier the different types of haloalkenes. Now the example here I am going to have, let us say we have chloroethane with the same reagent, sodium hydroxide, can also be potassium, still under reflux. I'm going to replace the chlorine with CH3, CH2, OH plus sodium chloride. Now, as usual, my mechanism involves a single step, and we have two species in a determining step. But as usual, I will always form one my nucleophile. So I will dissociate this, forming my nucleophile. Now, as I form my nucleophile, what happens is that I'm having my organic molecule. Since this molecule is not surrounded by electron donating group, or which has sufficient electron to supply him electron, he cannot donate all the electrons to the chlorine directly. So what is required is that the nucleophile will first of all come and perform what we call a dorsal attack. So he will come and attack behind, and at the same time I'm going to remove the chlorine. So this is what I call my rate determining steps, or my slow step. As my rate determining step or my slow step. Now, after my slow step, the next thing is that I'm going to create an intermediate molecule. So the intermediate molecule, which is highly unstable, will be of this form. Now, as the chloride ion is given, the OH minus is entering. So I am having this my intermediate molecule. Now, in the first reaction, what will happen? The chloride will completely be removed, and I finally have CH3, H with a change in configuration. But what I said, chemistry until we can still copy back the molecule in this form, you will not have any problem, okay? And still alongside the chloride ion, we combine with N plus to form sodium chloride. So that is what is happening during SN2 mechanism and all that it concerns. Now we enter into our small p, that is electrophilic substitution reaction mechanism. What is an electrophilic substitution reaction mechanism? It is a reaction in which an atom or atom is replaced by an electron deficient or electron poor species. Alright, so it generally occurs in what? It occurs in aromatic compound, that is compound containing what? Benzene, compound containing the benzene ring. Compound containing the benzene ring. So that is how it occurs. And now the mechanism here is very simple. It is a standard. In this mechanism, generally I am having what? My benzene ring. I will have an electrophile. So what happens is that what? The electron, the density of electron in my benzene ring will come and, okay, this is what we call the attack of the electrophile. So what happens again is that I'm going to produce an intermediate species. This intermediate species will have an H here and my electrophile will be here. So what happens is that this bond will come and replace it here. And lastly, what will happen is that I'm going to have my molecule in which it is substituted. Now, this electrophilic substitution reaction, we generally see it in nitration of benzene, in Friedel-Crafts, which is alkylation and alkylation, and we also see it in what? Halogenation. We will see in halogenation of the benzene. Okay, so you see this mechanism in this type of reaction. So we are going to discuss about two of the reaction, and the rest will practice it at home. Alright, so if you take the first one, let's see, which is nitration of benzene. So how does the nitration of benzene occur? So I'm having my benzene ring with nitrating mixture. The nitrating mixture is what? Concentrated nitric acid and sulfuric acid from temperature from 55 to 60 degrees Celsius. I'm going to form my nitrobenzene. What is the mechanism here? What is the mechanism of this reaction? So as usual, I was going to form my electrophile. So what will happen is that I'll have a reaction between my nitric acid and my concentrated sulfuric acid. They will both form my electrophile. So now I'll have my species that will remove the hydrogen from there, and I'll have my other species. Okay, also now to balance it, you can put it 2A, and it's where the reaction is balanced. But we are going to focus on our electrophile. This is our electrophile in this reaction. So what is happening is that following this mechanism, very simple, I'll have my benzene ring, and I'll have my electrophile. So what happens is that this ring full of electrons will be attacked by the electrophile. So this is automatically my slow steps. So I will produce an intermediate species. I'll produce an intermediate species which has a plus here and NO2 here. So what happens is that this other species will come and move the H, and this bond will be stabilized. Finally form my nitrobenzene. And of course I will have alongside sulfuric acid that will be released back. So this is the mechanism of electrophilic substitution reaction. So very simple when you follow it like this. Now we will check on the second example, which is Friedel-Crafts reaction. But here we are going to focus directly on the Friedel-Crafts alkylation. You will try the Friedel-Crafts alkylation and you will try the halogenation at home. Now, what is Friedel-Crafts alkylation? It is simply the substitution of one hydrogen in my benzene ring by an alkyl group using Lewis acid. So, what is an alkyl group? An alkyl group, it is simply such a group This is what I call an alkyl. This is what I call alkyl group. So what happens if you then craft alkylation? So I will have an example. I will react my benzene ring. I will react my benzene ring with, let us say, an acid chloride, which is generally producing a better yield. So I can have this my acid chloride, and I react it with what? With release acid such as aluminium chloride. You can also use iron trichloride. The two of them will pass. Here it's under reflux. So what is happening is that what I will replace my hydrogen which is present here with this alkyl group, and I'm going to form such a compound. In which this my compound is called phenylethanol. So the compound is called phenylethanol, and as usual my acid will be formed back at the end of my reaction. Alright, now and of course there will be an HCl. I'll be doing this. Now the mechanism, just like in nitration, I will first of all form what my alkyl electron. So what happens is that I will have this my compound that will face what my Lewis acid. Now what will happen is that the Lewis acid will accept what this Cl, releasing what my electrophile plus aluminium Cl4. Now what will happen is that this my electrophile will attack my benzene ring. So I will have So what happens is that the attack will go as usual. So my arrow goes like this, and this is what my slow steps of my reaction. So what happens now? I use my intermediate species. This intermediate species. What happens? The same thing that happened in the other one. I will have since then 4 minus. You will come and remove this H, and the bond will be stabilized. And finally, my first step, what will happen is that I will have finally my compound. Finally my compound. What is the name of this compound? You know this compound is phenylethanol. So I hope it is clear. Alright, now we go to the C part of our substitution reaction, which is the free radical substitution reaction. We all know that the free radicals are produced during homolytic bond fusion, which occurs when we have the presence of UV light. So free radical substitution reaction is a reaction in which an atom or group of atoms is replaced by a species which are unpaired electron called a free radical. Now it generally occurs during halogenation of alkenes. Whenever you have the presence of UV light, that is ultraviolet light. Okay? So, even at all in organic chemistry, whenever you see the presence of UV light, there will be a free radical mechanism that will take place. So, try and keep it in your head. Alright, now, example of type of reaction where it occurs, I can have my methane that will react with chlorine in the presence of UV light to produce chloromethane and hydrogen fluoride. Now, generally, this mechanism involves 3 important steps. So, the mechanism generally involves 3 important steps, which is initiation, propagation, and termination. So that's it. This is how the mechanism is subdivided. Now, when it concerns initiation, So in this initiation step of my mechanism, what happens is that I will form my free radical from the UV light. So in this I will have my chlorine molecule, I'll have my UV light. Now this chlorine molecule will perform what we call a homolytic bond fission, creating what we call free radicals. Free radical. Now, after that, I have my next step, which involves propagation. Now, just by the name, in the propagation step, what happens is that my free radicals that are produced will form new other free radicals. It means that the production of free radical will be propagated. So it means that this my free radical will come and knock my CH4, releasing another free radical, CH3 free radical plus HCl. Now this my free radical again can come and knock on the remaining chlorine molecule which were still there, producing other free radicals and CH3Cl. So that is the propagation. So I propagate the production of my free radical. Now, lastly, I am having what we call the termination stage. So what happens in the termination stage is that my free radical that was produced in the propagation stage will combine themselves. So you need that this my free radical will combine with this my free radical to form my chloro-18, which is what my main product. Now, alongside with it, this free radical can combine with this free radical, to produce ethane, and this free radical can combine with this free radical to produce back the chlorine molecule. So that is what occurs in free radical substitution mechanism. Now we enter into the B part, which is talking about addition reactions. Now, what are addition reaction? This is the type of reaction in which two or more molecules will combine to form a single product. So this addition reaction generally occurs for unsaturated molecules. That is a molecule in which their capacity to bond to hydrogen is not at the full level. So that is you have a bond of multiple bonds. So it occurs in carbonyl and alkyl or alkyne. And we say that there exists in two types. That is nucleophilic addition reaction and endophilic addition reaction. So what is a nucleophilic addition reaction? A nucleophilic addition reaction is simply a reaction in which the first species to attack the multiple bond, it is a nucleophile. So the first species to attack the multiple bond is what? The nucleophile. So that is what determines that is what it is a nucleophilic addition reaction. Now it occurs in what? It occurs in carbonyl. When we talk about carbonyl, I hope you are aware that you are talking about aldehyde and ketones. So what happens in a nucleophilic addition reaction? So if I am having, for example, by any carbonyl compound, which is let us take the case of ethanol. If you are having ethanol, I will react it with, for example, hydrogen cyanide under reflux. I'm going to produce a nitride, which will form CH3, OHCN. So I produce my single product. So the name of this compound is 2-hydroxypropane nitride. See, this is this nitride what I mean. than the limit. So that is how the mechanism. So means that I will add compare this molecule to this one. And now see it is a carbonyl. The first species I will attack is one is in nucleophile. So now let us explain the mechanism. So as usual, I will first of all try and form what by nucleophile. So what happened about what H plus and Cl minus. So you remember that this one is what my nucleophile. So the next thing is that what the nucleophile need to attack. So how is my molecule? I'm having CH3. So I hope all of you know that the carbonyl are disposed in this form. It is my carbonyl. Now, this carbonyl, as you are seeing, since oxygen is highly or more electronegative than carbon, this molecule will have a discharge distribution. It means that the charge distribution of oxygen will be partially negative and carbon will be partially positive. And so the nucleophile will be attracted to the partial positive side. So what will happen is that I will have my nucleophile that will attack. I will attack it, and this double bond will tell itself to the oxygen. So this is of course this step. And I will finally have my compound CH3 COH Cn now will be here, and this my oxygen will be full of electron. Now to stabilize my oxygen, this H plus which was here will be attacked, and finally I will form my compound in my first step, in which I will have CH3 COH H and Cl, which is my compound 2-hydroxypropane nitride. So this is how nucleophilic addition mechanism takes place. Now we are entering into the electrophilic addition reaction. What's an electrophilic addition reaction? So the reaction in which the first species to attack the multiple bond is an electrophile or electron deficient species. It generally occurs in what? In alkene and alkyne, that is unsaturated hydrocarbon. So it generally occurs in what? Occurs in alkene and alkyne. So okay, when you perform additional reaction, it is true electrophilic addition mechanism. Now if you see, for example, if I am having this molecule of propene, or let us say propene, I'm having this molecule of propene, and I will combine it with hydrogen bromide under reflux. I will have as major product CH3, CHBr, CH3, which is 2-bromopropane, which is 2-bromopropane. Now, why is this one my major product and not CH3, CH2, CH2 bromine? Why is it one not my major product? So here we need to follow what we call the Markov-Nikov's rule. We need to follow the Markov-Nikov's rule. What does the Markov-Nikov's rule state? In addition of an unsymmetrical reagent to an unsymmetrical alkene, the hydrogen atom will attach itself to the carbon atom which is less substituted, or the carbon atom with more hydrogen. So hydrogen will fix itself to this carbon which is having more hydrogen. Let us say the person which is having more hydrogen will stay with more hydrogen, the rich remains rich, whereas the person with less hydrogen will remain with less hydrogen, the poor remains poor. So that is why this one is my major product. Now the mechanism of the reaction. So what happens in the mechanism is that my first species to attack will be surely the electrophile. So still due to electronegativity, this bromine will be partially negative, whereas this hydrogen will be partially positive in approach to my substrate. So this is how the charges will distribute themselves due to a difference in electronegativity. Now, as you're having that, this full of electron will come and take this hydrogen and this bond will finally go to bromine. So what happens is that the bromine leaves, the bromine ion will leave, and here this hydrogen will fix itself to this carbon. So I'll have a CH3, CH plus, and CH3. I'll form this carbocation, and finally this bromide ion will come and fix itself here to form my compound. So this was a slow step, this is the fast step. So finally I will have CH3, CH3CH, Br, CH3, which is my major product respecting Markov equals fluid. So that is about electrophilic addition reaction. Now we go into our last group of reaction mechanism, which are elimination reaction. Now what are elimination reaction? These are simply reaction in which an atom or group of atoms is removed from a given atom due to the presence of a strong base. So this elimination reaction is similar to nucleophilic substitution reaction, but the only difference is that there is the presence of an alcohol to change the nucleophile into a base. So what happens is that it still occurs for haloalkanes. So it still occurs for haloalkanes, which are RX. So what happens to your haloalkane? So when I'm having an RX and I am having an OH minus, just like in nucleophilic substitution reaction. But when I place an alcohol, this one doesn't more complete, say not function again like a nucleophile, not function like a base. Now function like a base, and I'm going to create a double bond somewhere. So we're going to see how this works, so don't mind this. Alright, so that is what is happening in your elimination reaction. So elimination reaction, just like close border nucleophilic substitution reaction, it is in two forms, that is E1 and E2. So one we talk about E1. So just like nucleophilic substitution reaction, this E1 means unimolecular elimination. Unimolecular elimination. So just like in the nucleophilic substitution reaction, this unimolecular elimination reaction occurs in two steps. It involves only one species, the determining step. It occurs for tertiary halogenoalkanes. So if you have, for example, this tertiary halogenoalkane, and we combine it with sodium hydroxide, but here we put an alcohol under reflux. We are instead going to have CH3C, double bond CH2 and CH3 plus water and sodium chloride. So what happens in the mechanism? So in the mechanism here, I will form now my base. You need that one to happen with that sodium OH in the presence of an alcohol. I'm going to have N plus OH minus. But in this case, this OH minus is not a nucleophile, it is a base. So it means that you come and remove a proton from my compound. So as usual, with the formation of my carbocation here, so I will move from here. Since this carbon is surrounded by the electron group, this chlorine can easily go out. Now the chlorine is going out, I will have of my carbocation. Now what happens is that my OH minus, which function as a base, then to come on the target directly, it comes and remove this proton, just like a base will do, the proton acceptor. Now this bond will come and form this, that is stabilize this carbon which is there. So finally, I will have the CH3, C, double bond CH2, CH3, 3. Alright, so this is my compound which is formed to elimination, and of course I will have plus water and sodium chloride. So this is now we go into E2, that is bimolecular elimination reaction. So this bimolecular elimination reaction is close to its friend, that is SN2, bimolecular nucleophilic substitution. So here it will occur in what? A single step. There will be no formation of carbocation, and lastly it occurs for primary halogenal alkanes. So what happens here in bimolecular nucleophilic substitution? If you take, for example, if you have such a compound CH3, CH2, CH bromine, and CH3. Now I'm having such a compound. I react with sodium hydroxide in the presence of an alcohol reflux. What will happen here is that I can have two products. I can have CH3, CH double bond, CH3, and I can also have CH3, CH2, CH double bond, CH2. So here I'll have the 2 in and here I'll have the 1 in. But now among the two, which one will be what? The major and which one will be what? The minor product. So this one is the major product and this one is the minor product. What governs the rule to know the major and minor product? This is what it is. Zaitse's rule. The spelling of his name is so that is Zaitse's rules. So the Zaitse's rule determines what the major group in what? In an elimination reaction. What does it say? It states that in an elimination reaction, the hydrogen atom will be removed in the carbon that will be more substituted. Well, that's more substituted. So it means that when you look at this carbon, so the carbon which are close to the carbon having the hydrogen. So this carbon is having only 3 hydrogen, while this carbon is having 2 hydrogen and is substituted. So that makes this carbon to be more substituted than this carbon. So since this carbon is more substituted, I will remove a hydrogen from my major product, and this one will be my minor product. So that is what is item code. Now let us explain the mechanism of the major product formation. So the mechanism here, mechanism of the major product formation. So what will happen is that I'll have CH3, I'll have C, H, I'll have hydrogen here, I'll have C, I'll have bromine here, I'll have H, and I'll have CH3. So what happens is that I'll have my OH minus, which function as what? As a base here. OH minus which function as a base. So what will happen in my base? You come and remove the hydrogen here at this position. Now I remove the hydrogen at this position, this one comes and fills here. And at the same time, this will disappear. This is because this carbon is not, let us say, stable as compared to the carbon which was a tertiary alkene. So when I'm having that directly, I am going to form my CH3, CH double bond, CH and CH3, of course plus water and in this case sodium bromide. So that is what is happening in elimination reaction. So we are at the end of our video, and I hope it helps some of you to understand the two concepts in reagent and reaction mechanism. So don't forget to put a click on the notification to have a new update. So good luck for your exam.